Yes. All right, good evening, everyone. So my name is Jelle, and I will talk to you about data contracts. I've spent with the team the past year implementing a platform based on data contracts, and I would like to share some lessons with you. Maybe just out of curiosity, who here is already using data contracts or thinking about using them in their organization? Okay, not a lot of people, so I think this will be interesting. So before we dive into data contracts, I want to zoom out a bit and look a bit at data engineering in general and what it typically is that we do. So what does data engineering often look like? You have a bunch of source systems on the left. Those could be SaaS solutions, it could be SAP, Salesforce, could also be custom software engineering solutions built in your company. Then you have data engineering, they pull in those sources, we do our thing. I left a blank space there on purpose. I will show what that looks like. And at the end, we have some tables. Could be modeled in any modeling technique, data vault, dimensional modeling, one big table, doesn't really matter. In the end, the idea is that is the useful data that is used for your dashboards, for your machine learning models, and so on. But what also happens often is you get a call. It's business on the line. Hey, my data is wrong. And it's up to you, to the data engineer, to fix that. So the first place where you look is, of course, in what you own yourself. It's in the data engineering space. So you start debugging, and what turns out, it's a bit of a spaghetti pipelines. Maybe dependencies were not very clear. But after a while, after you got through that spaghetti web, you find out, actually, all the pipelines are green. Nothing is wrong with my pipelines. So what is the next place you look? Well, in the source systems. Turns out that the problem actually came from an upstream system, and you just pulled in that data, and that is what caused that data quality issue downstream. So you really did not have the possibility to fix that. So if we summarize that, that looks a bit like this. So the common drill after a pipeline breaks, you start with an upstream change. Because of that, your pipeline breaks. If your pipeline breaks, then all the dependent pipelines on that also break. You start debugging, you see, okay, what happened upstream? You say, hey, but you should not change that, you should talk to us, look at all this critical impact, business impact you're causing. You accept that they will not change their solution because it was made for a very good reason, and they need that in SAP or Salesforce or whatever. You fix it in your pipeline with some case when statements, and everything runs again, and we wait until the next incident. And I think that's quite common. Who has experienced something like this before? Okay, quite a few people. In fact, I think this problem is so bad that this is a slide from a talk of yesterday, and it's a survey we did, over 150 people, and what came out is that data quality is the -- problem that companies are facing. It's not only the #1 problem. When they asked people to rate it according to importance, they also say that it's the most important problem they have in the company. So it's quite a big issue. So what I want to do now is I want to zoom out a bit and look really fundamentally why is this happening? What is really going on here? And then we'll start looking into solutions, of course. So I think the main reason that we're seeing all these data quality problems is because there is an explicit lack of expectations. Typically what happens if you have those people using your data at the end, and then it goes through a couple of stages all the way to the source system. Never in anywhere of those processes there is explicitly written down what will be the correctness. Will it always be all the data? Will it be a part of the data? How often is it refreshed? What is the availability? Will I always be able to pull from the source system, or will it be down sometimes? So that leads to assumptions. Those users, they make assumptions, and they're often more optimistic than reality. They think this is great, perfect data, everything will be in place. Because they're making assumptions, it leads to data not being used correctly. Because they think, this is great, I will use this for this dashboard, but it turns out this was not meant to do the very critical accountancy reporting or something that is not fully accurate. Now, why are we doing that? Data is being ingested to ELT processes or CDC processes, and that data that can change at any time. Like we said, they can just change it for a good reason. And those people, those producers, they're often not even aware that they are producers. Probably what happened is 20 years ago, some people in the data landscape, they asked a password, a read-only admin password, probably has less than 7 characters, and they still use that today to pull in the data, and the people that are there maintaining those systems, they're not even aware. So we just go through the back door of their systems, we're a bit burglars, and we steal the data from their systems, and they don't even know that we're using their data. So they're completely unaware about those processes, and they're also unaware about the impact it has. They don't know what value their data has besides their operational processes. So as a result, it makes it very difficult to hold them accountable because they're not even aware. And that also means that the responsibility falls entirely on the data teams to fix that. So how can we fix this? I think what we can do is we can look a bit into software engineering and principles they have applied the past years, and learn from that, and then apply that to data. So what I want to do now is I want to look at 3 concrete software engineering examples, and then let's make a map and apply that to data. First principle, software engineers, they almost never expose their internal data model. They, for example, here, when you have a software application, so this client could be a front end, it could be a banking website, for example, they use a bunch of services, and software engineers would never make their internal database available. Why do they do that? They don't want the database to become the API. They don't want this database model to become what all the others use, because it might contain a lot of internal names, it might contain a lot of internal tables that are not really needed to really get it going. Also, another reason is that this data may be too fine-grained and you don't really want it. And we want the ability to change what is in here without affecting this. So we want to keep our API stable, but maybe we want to change completely our technology stack. People that use our services shouldn't be aware about that. When we keep this stable, that's fine. Even when we're not talking about REST APIs, the same principles apply in code directly. When teams are not even building REST APIs and just building like big code bases, monoliths, also there you decouple yourself, you make interfaces, you don't couple abstractions to concrete implementations because it gives you flexibility. So the same principle applies to code directly, and I think we can also do something with this in data. Okay, let's look at the second thing software engineers do. Software engineers, they split up their big code base in multiple smaller services. We call that microservices. And basically at some point your team is becoming so big and you have 20, 30 engineers that it's really hard to work in a single team. So they say, okay, we need to make multiple smaller teams and they all own some part of the system. Like this team, for example, they own the return and the shipping service. This team owns the order service. So the first reason why they do that is to reduce release coordination. You don't want to have to talk to all those people, all those 20 people, involve them all the time to release something. If you can release independently, you can release faster, of course. So the second reason is improve the release frequency. You ship faster, you get faster feedback, you can get faster business value, and so on. And the third reason is they have the full lifecycle ownership. They decide when to release something without having to necessarily talk to all the other people. The only rule there is don't break your interfaces that other teams use. As long as you keep that stable, should be fine. All right, and a final observation. Or wait, one more thing. So this is Netflix and Amazon, and they try to draw what their microservices look like. So this is how much they have in place. They have thousands of engineers all over the world, and all those things talk to each other. Well, it is because they apply this kind of principles. And the third thing they do is they describe their interfaces in a specification. And when we're talking about web APIs, so synchronous APIs over HTTP, that's typically done in an open API contract. And one thing that you notice here is that this is technology agnostic. You don't see that this is Java or Python. This is a specification that can be used with any programming language. The person or the team consuming this shouldn't have to care about you using Lisp or Haskell or some weird language. As long as they understand this, they can connect to it. A second thing that we saw happening here is that a whole ecosystem of tools resolved around this. For example, you have this OpenAPI website where you can create this, but also you have like generators. You can generate SDKs, both for the producer of this code, as well as for the consumers. You can just say, generate me some Python code that can consume this interface. And there's much more tooling out there, and it's all because they use this standard specification. All right, so those are 3 software engineering concepts. And what I think we can do is we can take those and map it to data. So the software concept, not exposing your internal data model, we could translate that to, well, if we as data engineers ingest data, we make sure that we never expose that raw data directly, so your bronze layer, also not your silver cleaned layer, but only the final curated table that brings value, that is what should be exposed. Second principle, microservices. We break a big thing down into smaller components. Here the same thing, encapsulation. We break down our pipelines into smaller components, and we could call that data products. I will not go into definition of what a data product is, because then we're tomorrow morning somewhere. And then the final thing is OpenAPI specification, and there we need to establish like clear interfaces described in a data contract. And that brings us to the topic of why do we need data contracts? So what is a data contract? Some principles. First of all, a table, that's what we use in as data engineers, we produce tables. That is an interface. People, teams, they plug into tables, they consume tables, so that is an interface. So a table we should also treat as an interface. A data contract is like a formal specification of that table. So that is what we need to protect, that is what we need to describe. That interface, just like the OpenAPI specification, is both human readable as well as machine readable. And finally, the producers of that table, they need to take ownership. They need to make sure that they provide the stability guarantees. Maybe one more thing I want to highlight here is this drawing on the bottom right. It's not because we have data contracts in place that we suddenly have some magic layer that everyone has to go through. Your consumers that use your data, they just connect as before to your SQL tables through GDBC, ODBC, Arrow, doesn't really matter. You only have these additional guarantees on top that describes what those tables look like. All right, the reason why you see some principles and not definition is also a bit because it's very hard to come up with like a single definition. And there's a lot of people in the industry that don't really agree on what exactly a data contract is. So I put down some things here that are typically associated with a data contract, but they're not necessarily always present. And the first one I already described, it's an interface, it's a way to describe your data. But sometimes they also say, okay, we also put additional documentation in there, like describing your table name, your column names, and so on. Sometimes they say it's an agreement between a producer and a consumer. It's because you say as a producer, hey, I'm going to produce this data. And then your consumer says, hey, but what can you also add this please, or can you please make those changes? So in a way, it's an agreement because your consumer, the one that needs the data, is saying, but please make those changes. I also want this. So in the end, even as a producer, if that one takes the ownership, you could see that as a form of an agreement. So those are some things. That last bullet point, like federated governance, I will talk about that a bit more. All right, this sounds great, right? So does this mean that we need a data contract on every table? What do you think? Yes, no? Yes, no, the answer is no. So the basic rule is you only need a data contract every time there is a discontinuity of ownership. So every time it switches teams, you should have a data contract in place. So that begins with the source system, and this data they provide, they need to put a data contract on there. Then we as data engineers, we build data products. Also there we put a data contract, and then you typically have the visualization team and they use that data. So there's a problem here. Which part will not work out? Robert? Yeah, the left box. If we ask the people of your software applications or the SAP team or the Salesforce team, hey, can you put this data contract on your data? What will they say? No, indeed. So if only life was this easy, right? So I think it's a bit of an utopia. So there's this article that came out, I think, a few months ago already. It's from a company called Confluent, and they talk about we need to shift left. Instead of doing this, what we typically do, you have a source system, you have an ETL, bronze layer, silver layer. What we need to do is the software engineers, they need to, next to their normal operational database, they also need to offer their data as a table, as a data product directly. And then we as data engineers, we can use that because they are the people that know the data. They know best how to give it to other teams in the organization. So that is ideally what it should look like. The problem here is that I only see this model work in like very software and heavy companies, like where at least 50% of the people are like software engineers. Because usually the companies where I work at, I always get to deal with SAP, Salesforce, or like one big old Sybase database of 20 years old that has 2 people left that maintain it. So it's impossible to ask that from them. So I think this model is not super realistic, but that doesn't mean we cannot do data contracts. So what is the next best thing we can do? One more thing. So you have this guy, Chad Sanderson. He is the guy that basically popularized data contracts. So he, like for more as a year, he put a LinkedIn message like there every week, and he's building out a startup, and they're trying to do exactly this. So they're saying, look, the upstream systems, they should provide data immediately as part of their software engineering process. He calls it data ops or data DevOps something, and he's trying to build a startup around that. So I think he's an interesting person to follow, but I think, we're very far removed from that in most organizations. All right, so the next best thing we can do is we built an anti-corruption layer where data is only ingested once and then modeled once as close as possible to the source system. So you see here we do ingestion of that source system. We do data modeling. We store that in a storage system that is optimized for reading. So it can be Parquet files, can be Snowflake, can be whatever. And the data that comes out is only our final curated layer, and there we put a data contract on top. And then the people on the right that use our data, they still have data available with a data contract. So I think what we should do is we should start from the right, where the value is of the data, and then we move up to the left, we start putting data contracts in place, and in the end we'll end up at the source system. And I think once we have all this in place, that's a good moment to start a conversation and say, hey, but what if you could also do that? So I think that's a bit of a leverage or a way that we could follow there. So as a piece of advice here, I would say only ingest the source system once. So don't ingest it 5 times by different teams because data will start to diverge, and at some point it comes together again, and then you will have big data quality issues. So only ingest it once. Make that data product with a data contract on top of it the only reference for that data for all analytical use in the company. All right, great. So we have the intention to offer our data as an interface. Next up, the question is, what specification should I use? Well, I think at the very minimum, those things should be in here. So first of all is the schema, which is basically your column names and the column types. Second is the descriptions, so a description for every column, for every table. Also some business rules, like an age can never be less than 0. This field always needs to be filled in, so like required, non-nulls, things like that. Also SLAs, most important one is how often is the data refreshed. There's other ones as well. Resource name, where can you find the data? Like a resource address, is it this S3 bucket path, is it this Snowflake table in this database in this schema, things like that. The specification version, so you can evolve it when you might want to add more things later. And then who is the owner? Who should I contact when something goes wrong? So that could look something like this. So also this is like from the company I just showed you, like Gable.ai that came up with a specification. So this is what you would do when you make your own specification. But there's already a bunch of open source standards available. And yeah, as with all standards, they try to become the standard that everyone uses. But in the beginning, it's a bit of a war, like who is going to win, so there's multiple ones out there. So I think how you should treat them at this point in time, because they're not super popular yet, is you could use them as like inspiration, like what do people put in there, and you can take some things from each specification, depending on how valuable you think it is for your organization. So also vendors, and like the vendors that support the specifications, that's still quite limited. And they have it in their GitHub, like a vendors.md file saying those are all the companies that support this specification. But it's still like not even 10 companies, I believe, that integrate tooling with it. So you don't get a lot of out of the box, not like the OpenAPI specification. But still, I think it's good to look at. So there's two main ones out there. One is called data contract specification, and the other one is called open data contract specification. Maybe one thing I want to highlight is one open source tool that is there that seems quite useful. That is the data contract CLI. And basically it has command line comments to automatically check differences between contracts. It can automatically execute tests, so it integrates with Soda, for example. And yeah, it integrates with a bunch of technologies, things you can specify. If you're wondering what we used, well, we made use of Soda data contracts. So we went for our own specification that points to multiple Soda data contract files. The reason we went for this is because for us the most important thing was something that could automatically validate that your data in your, for example, Snowflake table was actually also what was written down in the specification. We didn't want to write anything ourselves to do that check. So we wanted a tool that has that out of the box, and that is exactly what Soda does. So how would that work? Soda would look for a table in Snowflake called dim customers, and when you say Soda run, basically, it will basically check that there are effectively 4 columns in your data and that it complies to all those rules so that it's actually the case. And then it will give you an error code or a success code. So it will tell you, okay, good job. All right, so here, as a piece of advice, I would give you gradually evolve your specification and don't put everything in there. If you look at that open data contract specification, only the Hello World example alone was 300 lines or something. So it's a lot of fields to fill in, like payment information. What if you want to do chargeback to other teams? So most companies, yeah, probably they want that at some point, but it's not their main problem they're dealing with right now. So probably if you don't need that now, just leave it out. So don't put all these unnecessary things in there. Only put in there what you can automate. All right, the next question is, how do we make sure that our data is compliant with the specification? So I already mentioned Soda, but yeah, we don't want to run it ad hoc, right? So when do you run this? So how you should think about this is that every new batch of data, so every time you do an ingestion from a source system, you should treat that as like a release. Not to be confused with a code release. It's possible that the code was not updated for months or for weeks, but still your data pipeline runs every day, maybe every hour. Every time it runs, for example, in Airflow, you should validate your data. So how does that look like? You have an extraction job in Airflow. It puts it in a staging table, which just contains the data you ingested. It could be a full load, it could be a delta load, it doesn't really matter. You do some transformations, tasks. That results in some tables. And then you have a publication task in Airflow that validates that this table conforms to your data contract. And only when that succeeds, you copy this table to a place that is accessible to other downstream consumers. So this other data product, that reads that table that was published. This pattern is called the circuit breaker pattern, or sometimes they also call it the write, audit, publish pattern, so the WAP pattern. So that's 2 names for the same thing. And the idea is that data is audited first before it is released for others to use. And if that audit fails, it also means that no data will be available for your downstream consumers. So again, the same thing here. This time, this is not a data product that ingests data, it's a data product that consumes another data product. Exact same principle. It does some transformations that results in some tables that needs to be checked. And then you have your data contract, and when this fails, it will not do this copying to this other place, and it will raise an alert, and it will probably alert the one that is writing this project, so the producer, but also all the consumers, all the people that are consuming this data. What you can do for this is you can use modern technologies like Snowflake, like Iceberg, that make this a very lightweight process. Because if I go one more time back, copying this table to this table, usually in classic databases, that's a very heavy operation. And you just copy the whole thing physically. Well, in Snowflake or in Iceberg, that's a metadata operation. It's just like a physical pointer that says, whatever data you have here that is now validated, also put this other pointer to this. And it's like a one-off, so when the other one starts changing it, then the other one is still the old one, which makes it very efficient. It's like a 2-3 seconds job, sometimes a bit more, but usually not more than that. So in practice, what we did is we provision like a private Snowflake schema that is never accessible to anyone. On that schema, we do all our transformations. So we do our ingestions that results in a mirror table. We do our modeling, intermediate tables. In the end, we have our model data. That model data is checked, and only when it succeeded, we copy it to a public place that is consumable by others. So this is this write, audit, publish pattern, but then on a specific technology. Alternatively, what you can do is if you don't want this pattern in place, you can also just check the data after it is produced. And that's how most companies start. So how would that look like? You have your transformations, but this time, for example, you're making a view. And if you're making a view, that means you're not copying this data, but it's like a virtual use of another data product. So yeah, anyways, when this one is updated, yeah, this one is also updated. So you could also still run your data contract in Airflow, but yeah, even if it fails, yeah, this view will already be updated, so this one will always see the latest data. This is just one way to do it. You could also say, I don't run the data contracts in Airflow, I do it on another scheduler, I do it on another system. It would be the same effect. You run it after the facts, and data is not blocked, and it can be used already for downstream applications. All right, so I think that's a really core fundamental part. And we have the specification, and we can validate the specification, and we make sure that what we write down is actually the case. That's the really basic thing that you need to get right for a data contract, but there's more. So what else can we do besides the data schema and the validation of that? Well, we can put a lot of other metadata in our data contract that make a lot of other automations possible. For example, you could alert the right people. If you have like owners or like team names in there, it could be linked to a Teams channel, a Slack channel, persons directly, you could alert them. You could automate your data privacy with it, your personal data, your PII. You could automate lineage from it. You could automatically push your data contracts to the right system. Yeah. So one example here is, what we did is we put here like, is personal data true, for example? And behind the scenes, this would automatically create like Snowflake column policies, and they would automatically like hash the data, for example. And the ones that write this contract, yeah, they would not have to care for that because we put that in our library. So if it's useful, people will use it, and that will help for adoption. Okay, 2 more slides. So if you do that, your data contracts should become the source of truth. If you typically look at what data catalogs do, is they pull your metadata, and they will just take everything, all the tables, and they will show it somewhere. And what happens often is that people are overwhelmed because there's so much in there, also shitty tables, obsolete tables, things are not up to date. So you want your data contract to become like the source of truth for your catalog, because only the gold curated tables are in there. So it should be like a contract-driven catalog. So how that would work is, for example, in your CI/CD pipeline of your data product, you could do some validations. Say, did you not break the contract? Did you not do any break changes? and when everything passes, like those pre-flight checks, you would just push that to a catalog, a data marketplace, and that's for people to consume. And then people could use that to discover data, request access, collaborate, like use it as a marketplace, like give ratings to data, leave comments, and so on. So like an actual marketplace on actually curated data. I'm not here to do marketing, but as Pascal already said, we have our own like open source product that is exactly trying to do exactly that. So you can check it out. So it has about 180 stars now on GitHub. So we're trying to grow it. And I will end with this slide. So if you do this, you will end up not just with the raw material, not just the data, not just your table, but your data will come packaged. Just like you don't buy sugar like raw in the supermarket, but you put it in like a container. And on the container it states what is the origin of the sugar. What can it be used for? Did you know you can make pancakes with sugar? Sugar is great, right? So that's exactly what you can do with data. You can say, this is what it's used for. Those use cases are using this data, and maybe that gives inspiration for other data. So I think it's really essential that we try to move into this kind of model. So you can start small, you can start within your own data engineering, not include the software engineers, and I think we can already come a long way with that. So that was it. And we don't have time for questions, so you can talk to me during the break. Sorry.